Hey, Shaki. Hi, everyone, and welcome to this Pi Day session on accessing data lakes in Amazon S3 using open source projects. My name is Devprat Kumar, and I'm a product manager on the Amazon S3 team. I'll be presenting this session today along with James Bornholt, my colleague and an Amazon scholar on the S3 team. First, let's quickly go over the agenda for today's session. We'll start by talking about why Amazon S3 is the best place to build your data lake. And next, we'll review some popular open source projects that customers use with data lakes on Amazon S3. So let's dive in. Data has become the most valuable asset for organizations. It drives innovation, agility, better products, better services, and overall a better experience for the end users. Customers know this, and that's why we see many of them moving away from traditional architectures and consolidating all their data into a modern architecture with a data lake in AWS. A data lake is an architectural approach that allows you to store massive amounts of data in a central repository, so the data is readily available to be categorized, processed, analyzed, and consumed by diverse groups within an organization. A data lake allows you to virtually store any type of data you need and run analytics on top of it, including advanced data science and machine learning. The first thing to decide when you build a data lake is where to store your data. And there are multiple aspects that you may want to consider. For example, scalability, security, ecosystem integration, and cost. Amazon S3 is a good solution on many of these fronts. For example, for automatic cost optimization, Amazon S3 offers S3 Intelligent Tiering storage class. Since the launch of S3 Intelligent Tiering in 2018, customers have saved $1 billion from adopting S3 Intelligent Tiering when compared to S3 Standard. This has been made possible because S3 Intelligent Tiering is designed to optimize storage costs by automatically moving data to the most cost-effective access tier when access patterns change. Similarly, Amazon S3 provides industry-leading scalability, holding more than 280 trillion objects and averaging over 100 million requests per second. For security, Amazon S3 offers a variety of encryption options, from server-side to client-side encryption. And for access control, you can leverage IAM to implement identity-based or resource-based policy. Last but not the least, S3 integrates with a large variety of AWS analytics and AI/ML services that fit all your data analytic needs and enable organizations of all sizes to reinvent their business with data. Building your data lake on Amazon S3 makes it easy to take advantage of purpose-built AWS services. For example, with Amazon Athena, you can analyze your data in Amazon S3 using familiar SQL queries. With Amazon EMR, you can learn large-scale data analytics and ETL jobs, potentially processing up to petabytes of data using popular big data engines like Apache Spark, Apache Hive, and Presto. On the other hand, you can analyze data across multiple data stores, for example, operational databases and data lakes using Amazon Redshift. Finally, with SageMaker or Amazon SageMaker, you can build and train and deploy machine learning models while benefiting from a fully managed infrastructure. Although many customers choose to run their open source analytic engines like Apache Spark and Hive using Amazon EMR, some customers opt to run their own Hadoop instances. In these cases, they benefit from the open source S3A client that provides high-performance I/O with Amazon S3. With S3A, Apache Hadoop jobs can read and write data directly in Amazon S3. The S3A client uses Amazon's open source Java SDK with support for the latest S3 features and authentication schemes. Similarly, Trino is another popular open source project that customers use with Amazon S3. Trino is an open source SQL query engine used to run interactive analytics on data stored in Amazon S3. We continue to partner with open source community to deliver improvements with both these projects for our customers. Talking about S3A, we want to highlight the strong collaboration between Amazon S3 developers and the open source community. A notable milestone in this regard was removing the need to use S3 guard module when we introduced strong read-after-write consistency in Amazon S3. Removal of the S3 guard module was a significant improvement for customers because it meant they would no longer need to run secondary indexes, saving costs. Additionally, the S3A community and the Amazon S3 engineers working together identified a number of additional improvements in the code base, which led to efficiencies and cost savings for our customers. This collaboration continues today, and it is getting stronger, with Amazon S3 making 48 contributions to S3A last year in 2022. Similarly, Amazon S3 continues to make contributions to another popular open source project called Trino. As I mentioned earlier, Trino is an open source SQL query engine used to run interactive analytics on data stored in Amazon S3. In 2022, Amazon S3 engineers made 7 contributions to Trino. With these contributions, the performance of queries running on Trino improved by up to 9x when using S3 Select. With S3 Select, you push down the computational work to filter your S3 data instead of returning the entire object. By using Trino with S3 Select, you retrieve only a subset of data from an object, reducing the amount of data returned and accelerating query performance. And today, we are excited to make a new announcement for builders working with S3 data lakes. While S3A and Trino and other open source tools offer great built-in support for accessing S3 data lakes, we have heard from customers that they often have domain-specific tools that don't natively support S3's object APIs. Instead, they expect inputs and outputs to be files in a local file system. For example, autonomous vehicle simulation tools are Linux applications that read data from a file system, and some machine learning training pipelines store checkpoints on the local file system. Adapting these applications to access S3 data and take advantage of S3's elasticity and high throughput can be a lot of undifferentiated heavy lifting, or even impossible in cases where customers don't own the application source code. We are committed to making these tools just as easy to use with S3 data lakes as Hadoop Engines or Trino. This is why today we are announcing the alpha release of Mount Point for Amazon S3, a new open source file client that makes it easy for Linux-based applications to connect directly to Amazon S3 buckets and access objects using file APIs. Mount Point for Amazon S3 presents S3 objects as files in your local file system and translates local file system API calls to REST API calls on S3 objects. With Mount Point for Amazon S3, you can achieve high single instance throughput to finish jobs faster. You can reliably scale up and down over thousands of instances and read large objects processing petabytes of data in S3 data lakes. Mount Point for Amazon S3 is ideal for large scale-out workloads that process petabytes of data using random and sequential read operations. Common use cases include machine learning training, autonomous vehicle simulation, genomics analysis, and image rendering. These applications perform read-heavy access on hundreds of terabytes to petabytes of data in S3 data lakes and require S3's high elastic throughput as they scale up and down over thousands of instances. While they read large files over one or more instances, they write to a file from a single instance at a time. This means they do not need shared file system features like locking. Customers want to run these applications on Amazon S3 to benefit from S3's elastic throughput and a strong integration with the data lake ecosystem. Due to this reason, they need an API bridge between the file and object storage systems. In other words, these workloads often do not need the full POSIX feature set. Mount Point for Amazon S3 is specialized for these workloads and offers only a restricted set of file operations. For example, it doesn't support writes in this first release, and in future, it will only support sequential writes to new objects. So if you're looking to run data lake applications that need to collaborate or coordinate on shared access, shared data across instances or users, we recommend using Amazon FSx for Lustre with Amazon S3. But if you're running a data lake application that needs to read large objects without using shared file system features like locking or POSIX permissions, we recommend using Mount Point for Amazon S3. Next, we talk about how Mount Point for Amazon S3 delivers high performance and high reliability. A common theme we have heard from customers is that they want a file client on Amazon S3 to offer the same stability, performance, and technical support that they get from S3's REST APIs and the AWS SDKs. To make this possible, we are building Mount Point on top of 3 foundational technologies. First, Mount Point builds on the same AWS Common Runtime, or CRT, used by most AWS SDKs. The CRT is a software library for interacting with AWS services, offering components like I/O, HTTP, and encryption. The CRT is purpose-built for high performance and low resource usage to make the most efficient use of your compute instance. For Amazon S3, the CRT includes a client that implements best practices and performance design patterns, including timeouts, retries, automatic request parallelization for high throughput. Applications that use Mount Point for Amazon S3 get the benefits of all this work for free. Second, Mount Point is built in the Rust programming language, which offers strong compile time safety guarantees without runtime overheads like garbage collection. Teams across Amazon S3 and AWS are building core services in Rust today. We use Rust because it offers reliability without compromise. We get strong safety guarantees like memory safety and a rich type system without paying the cost of a language runtime or garbage collector to enforce those guarantees. Third, we make use of automated reasoning to improve Mount Point's reliability and clearly define its behavior. Engineers across S3 use automated reasoning to mathematically define the behavior of key systems and then formally demonstrate that our implementations meet these requirements. For Mount Point, we use automated reasoning to validate the file system semantics offered when mounting an S3 bucket. For example, the mapping from S3 objects to file system names is full of edge cases like keys that end with a / or keys that are not valid file names. This automated reasoning effort makes it easy for applications to use Mount Point with high confidence. These foundations are a great example of what we do every day to build high-quality services across Amazon S3. High-performance libraries like CRT reflect over 17 years of experience building for immense scale, and techniques like automated reasoning help us not just for the average case, but for the one in a trillion edge case that matters at scale. Together, they allow us to make Mount Point a reliable and high-performance file client for large-scale data lake workloads on Amazon S3. On that note, let me invite my colleague, James Bornholt, for a demo of Mount Point for Amazon S3.
Thanks, Devabrad. Hi, my name is James Bornholt. I'm an engineer on the S3 team, and I'm super excited to give you a first look at Mount Point for Amazon S3. Mount Point for Amazon S3 is a client-side application that runs on your Linux compute host. So here I have an EC2 instance that I've already set up. I've already followed the instructions from the Mount Point GitHub repository to install the application on my instance. And so the first thing that I need to do to use Mount Point is to create an empty new directory into which I want my bucket to be mounted. Now I can launch Mount Point, specifying the name of my S3 bucket and the directory that I just created. With Mount Point running in the background, my directory now reflects the contents of my S3 bucket. So here I've got a bucket with some of my favorite sessions from reInvent 2022. And we can see that Mount Point creates a directory structure based on the keys of my S3 objects. So I have two directories called Keynotes and S3. And within each of those directories, I have some of the videos from the sessions. All of the usual Linux command line tools for working with files and directories now work with my S3 objects. I can list them to see when they were created, or look at their directory structure as a tree. I can stat them to see their metadata, and tab completion works as well. I can also use Linux tools to work with the files themselves. For example, I can compute a checksum of one of these videos using the md5 sum command. Or for a more complex example, I can use the open source ffmpeg tool to extract thumbnails from one of these videos. Behind the scenes, Mount Point is streaming my object directly from S3, so I don't need to do any manual work like copying my videos down onto local storage first. Mount Point also implements S3's performance best practices, and so it can take full advantage of S3's unmatched scalability and elastic throughput. For this first release of Mount Point for Amazon S3, we're not yet supporting write operations, and so I can't put this image back into my bucket just yet. Stay tuned to our open source roadmap for updates on this and other features as well. We're really excited for you to try out this first release of Mount Point for Amazon S3 and to see what we build with it. Now I'll hand it back.
Thanks for the helpful demo, James. We're announcing an alpha release of Mount Point for Amazon S3 today, and the code is available on GitHub. We are making the alpha release available to collect feedback early and incorporate your input into the design and implementation. We welcome your contributions and your feedback on our roadmap, which outlines the plan for adding additional features to Mount Point for Amazon S3. This concludes our session on accessing data lakes in Amazon S3 using open source projects. Thank you for joining us on Pi Day 2023, and have a great rest of your day.
Amazon S3 is committed to bringing the value of open source to our customers by continuing to support and contribute to a variety of open source projects, including S3 and Trino.
Indeed. And thank you for the session, Dave. As a customer, when should I use Mount Point for Amazon S3, and when should I use Amazon FSx for Lustre with Amazon S3? Can you walk us through that?
Yeah, absolutely. That's a great question. So Mount Point for Amazon S3 is ideal for large-scale data workloads, data lake workloads that use random and sequential read operations and write from a single instance. Now, write from a single instance is really important, because what we are trying to say, and what we have said in the presentation, is that we are not supporting shared file system semantics. If customers need shared file system semantics, if they're writing across multiple instances to the same file, they should use Amazon FSx for Lustre. Besides that, Lustre is amazing with its latency. It offers really low latency access and a POSIX-compliant file system. So if customers need those semantics, they should use Lustre, FSx for Lustre with Amazon S3.
And what is the throughput that you support for Mount Point for S3?
Yeah, so Mount Point for S3 is a client for Amazon S3. And just as with AWS SDK, you get the throughput that you would get with S3, meaning like high single instance throughput up to like multiple gigabytes per second per instance. And if you're accessing your data set across multiple instances, you can potentially scale to hundreds of instances and hundreds of gigabytes per second. So you get the same experience with Mount Point for Amazon S3. And that's one of the key benefits that customers have asked from us, that they want the same elasticity of throughput that they get with AWS SDK when accessing S3 over these file APIs. So does that answer your question?
Of course. Thanks for your answer.
Great.
Awesome. Thanks, Deb, for joining us.